I was given this Flame Eater engine. By my researchers, it must have been produced by a company called Rebi in the 1950s. And, well, it looks rather sorry, but I think it's got it where it counts. It's got good compression and it spins pretty freely. So before I tear this all apart and repaint it and clean it up, I wanted to at least see if this thing has any life in it and get it running. I've tried to, and it didn't do shit. And I think that's because the profile of the cam here is entirely wrong. Let me bring you in closer. The principle of a flame eater is rather simple. You've got a flame up in here, and then you've got a port which opens and closes. And as the piston travels backwards, the port is open, the flame gets sucked in, and at the end of the stroke, the port is closed off. The air in the cylinder cools down, creates a vacuum, and pulls the piston forward. And then at the end of the stroke, the cavity is opened again, and the new flame is sucked in, the cycle repeats. Now, the issue I'm having with this cam is that, as you can see, I've set it so that it opens pretty much at top dead center. You can see it uncovering the port here. And it sucks in, and then it already closes by the time the piston is rather, not much up its stroke. And then for this entire path, the air is already cooling down and trying to pull the piston backward, and only after top dead center can it do any job. So I think if we make this here open a little longer, file it down a little bit, that ought to give us a chance at this thing actually working. You see, when you try putting a flame under here and then throwing it on, then you can see how the piston jerks backwards once the port here is closed off. So I think, despite not knowing anything about vacuum engines, it should be the right thing to do, just modify the cam a little. And there you go, she's a runner. So now that we know that, we can take it apart and get it neatly. Well, I've come to terms that if I want to take this thing apart and paint it, then it's making a bit of sense to wait until it's no longer 0 degrees and snow outside, because the paint won't really stick anymore. In the meantime, let us see if we can't get this puppy here running. This is actually a flame eater built by me during my apprenticeship, so it must have been 2014, 2015, somewhere there around. There was not a whole lot to do at work, so I decided to get myself busy. And when I was nearing completion, then all of a sudden there was a bunch to do, and I sort of, put it aside and cobbled it together quickly. I remember that I made the crosshead and the bearing and the crankshaft at home in my home shop, which at that time was at my granddad's place still. But it never ran, and I just set it aside for it to look pretty and do nothing else. Now, recently I was at a model engineering meeting, convention, what you want to call it, and I got some rather interesting tips which might help me get this thing running again. I've had my time to come up with a few things I wanted to try myself, but before we dig into all that, the simplest trick or tip that I got is, for the longest time I've had a piece of copper in front of here because I had nothing else that would fit to act as a valve. And somebody told me, well, that ain't gonna seal up because it's not flexible enough, it's just going to warp. And I should try some feeler gauge. And I did that, and it already started making some very flame gulperish sounds. And in the other direction you can see that it's actually sucking a vacuum, while in this direction it's running pretty smooth. The issue here is that it's too shallow, too narrow, because I milled this slot 15 millimeters way back when, and this is only 10 millimeters wide. So I'm going to have to get myself a 15 millimeter piece of stock, and we can try that again. Thanks to a dear friend, I've now got two wider pieces of filler gauge, and we shall see if, you know, the wideness is really all it needs, and make a new one of these. Now while the burner is out, this reminds me this was one of the very early practice pieces I did for the CNC course back then. You know, this was circular milling out a pocket, and this was a rectangular pocket to be milled out. Ah, those were the days. Let me tell you right up front that that in itself wasn't enough to get the thing going. I've dug up the earliest evidence that I had of this vacuum engine. You can see it sitting there in the back waiting for completion. I since decreased the throw of the cam in order to decrease the amount of power loss made while opening and closing the valve. Now let's go one step further and reduce the size of the hole up front. That should increase the sealing surface for the valve, and when we give it a nice chamfer from the back, then maybe that'll also help the flame spread into the cylinder more evenly. Purely for optical purposes, and not because that would make this thing a runner, I went ahead and made the cooling fins here a little deeper, because I couldn't stand the look of these partially exposed threaded holes here. Now they're fully exposed and everything looks nice and neat again. After trying for way too long, here's a thought. Maybe I need to get rid of overpressure in here more efficiently. Can you see when I run this how suddenly it stops in the power stroke? It goes like this, despite, you know, making power, shall we say, for half the stroke, and then overpressure you hear it pop where it shoots that out the front. And when it's up here, then it actually takes, as you can see, quite a bit of force to make it pop in the front. So all the momentum gets lost by trying to push the overpressure past this valve here. And I think that's because the steel sheet here is pressed against the boss down here. So it's not actually free floating, but it's constantly being bent like that, in turn over this lever being forced against the sealing surface. So maybe if I can either make this boss a little longer or enlarge the hole here, which would be simpler, I could get rid of that minute amount of spring pressure and therefore not make it seal as tightly. I made the hole a 0.5 millimeter larger down here. Now the play in the slot is too much. So I've put this wire in the back here temporarily to provide some back pressure. That seems to do the trick. To reduce the play for the membrane, I just filed down the spot in which the downholding plate sits. That did the trick. The vacuum engine was now running, but once it had reached a certain temperature, all of a sudden it seized up. Now before going ahead and filing down on the piston or doing something stupid, I just simply tried some graphite powder instead of the oil, which would inevitably get thin as the temperature grows. And that actually was all it needed. Now we have a reliably running flame meter. Let me just plug this over really quick. I have bad news regarding this vacuum engine because I've tried loosening the flywheel, for instance. The screw here is completely loose, as you can see. I can twist it with my finger, but it's just not coming off this shaft, not at all. Now, the same goes for these pulleys here. All the screws are loose and they're just locked solid on the shaft. That's something called contact corrosion, and it happens when steel meets aluminium. The sad part is that this flywheel isn't aluminium. The issue with die-cast zinc is it corrodes from the inside out. You may see those splits here. And what that means is, once it corrodes, it's going to start expanding. That can shrink it on the shaft, and it can also lead to self-destruction. And it's probably the cause for all the paint flaking off. It's just the whole damn thing expanding on itself. It becomes brittle, and sometimes it even chemically degrades once it sees temperatures below zero for an extended amount of time, and it just, turns into powder. I do not, under any circumstances, want that to happen, in an attempt of trying to improve things that don't need improving in the first place. So, as much as I hate having to do it, I'm going to have to postpone whatever restoration activities I planned for this until the flywheel decides it wants to come off, because I'm not going to force it off here. I can't use heat, I can't use brutal force. All I can do really is put some oil down the screw hole and press the screw in there and hope that the oil over time creeps into the nooks and crannies, and someday maybe it'll come off the shaft. If not, then that's just the way it's going to be. I'm going to have one ugly duckling here, and my homemade vacuum engine is the one which is going to take the points for good looks. What I'm going to do now is fire this baby up, have it run for you, fire the other one up, have it run for you, and maybe even both together.
Do it! Just do it!
Alright. Jeez. It should be noted that about 5 minutes have passed since I've lit the flame. These things don't like to run when cold. From the amount of noise these guys are making, you would guess that they make a whole lot of power. They don't. This one has rarely enough to power this transmission. This one is just about strong enough to power itself on its own. Anyways, that shall be it for today. Should I get the flywheel and the other die-cast pieces apart, I'll let you know. But for now, I'll just leave it the way it is and live with it. Thank you very much for watching. See you guys next time. Bye bye!